Welcome to 3D Printing Nerd Studios, proudly powered by PCBWay. 8% off. Link in the description. You know what to do. This is going to be a really fun one because I recently got a message from someone who you've seen before on the show. And it's leading me into this cool project where we get to talk about materials and heat and how those two interact. And so I think just to start off, here's that message.
Oh, hey, it's Jack, CEO of Jack & Man Incorporated. You may remember me from the Prusa Pro HT90 prints in Hawaii. Since then, I've fast-tracked my professional career in starting a company. Jack & Man Incorporated is a leading supplier of filament, heat beds, and, most importantly, extruders in the Northwest United States and parts of British Columbia. As a CEO, I deserve a way to hold my favorite can of delicious lemonade without my hands getting too cold. I need a can koozie. Please prototype something simple and get back to me.
It's Jack! It's Jack, everybody! My nephew Jack, the now CEO of Jack & Man Inc. Apparently, boy, these kids, they grow up fast. He was the one that helped out with the Prusa Core 1 when we were in Hawaii and had those cool Nintendo prints that we did on the kitchen table there. That was fun, but apparently now as the CEO of Jack & Man Inc., he is in need of a koozie for his cans because he doesn't want his hands to get cold, and I totally get that. And this is a great opportunity for me to get out Shapr3D because I've been wanting to learn this CAD package on my iPad. Both Shapr3D and Nomad Sculpt are kind of that thing that I want to know more about. And I've lined up some really cool stuff with Nomad Sculpt. For Shapr3D, I'm just going to brute force my way through it. And this is one of those things. So I've got an untitled project out in front of me, and I'm going to make a koozie. So the cans, US 12-ounce cans, like this Barks root beer, not sponsored, I wish. 66 millimeters in diameter, roughly. It kind of comes in here and it comes in here, and this can squish in the middle. But in general terms, 66 millimeters is safe. So what I'm gonna do is start a sketch. I'm gonna grab a circle and I'm just gonna draw it right here out. And then I am going to call it 66.5 because what I wanna do is take into account the clearance that we need for a can to fit and the tolerance of 3D printers. 0.5 millimeter should be good. Now then, what I want to do is offset that. So here we go, offset edge. This is great. I can tap that and I can bring it out. We'll say just 2 millimeters. Super duper easy.
So far, so good.
Yeah, okay, we're good. We're good there. So I can exit my sketching. And now what I want to do is extrude up. So I'm going to grab that middle part. I want to bring it up 3. So if I go back here and see my extrusion, I don't think I did that right. I want to do it 3. Okay. Now that is where the can is going to rest. That's the bottom. And so on the outside, now I can go up and I want to do 75 millimeters, which is roughly 3 inches. Tools. Union. Oh, there we go. Brilliant. I'm going to grab that edge. I will do 0.5, just a tiny one. And then up here, I will do some fillets, and I will do 0.5. Just rounding some things off. Let's print it out. Well, here it is. I printed it on the Core 1, and I used a Prusa PLA as my Barks root beer as a test. Oh, just slides in, holds it in pretty good, not too shabby. I can see the seam. It is aligned, which is what I want. Problem, though, that we're running into is a very typical problem within 3D printing, and that is when you have a surface that takes a certain amount of time to print and then surfaces above that take less time, you get an uneven cooling and you get something that doesn't look so good on the outside. And so we're getting that because there's a flat surface here and then we've taken the walls up. How can we avoid that? Well, what we can do is look in here. This inner edge, we can select it. So we can add a fillet or a chamfer. So I could do a 5mm chamfer, and then we could do a, let's see, R5. So that's the radius of the circle. So that is going to be a 5 degree, maybe? No, not 5. I don't know, but it's part of a fillet. So a fillet is rounded, a chamfer is like that. And so why don't we try both? I'll print one with a fillet and I'll print one with a chamfer, and then we'll kind of see which one works better. All right, those are printed out, and they printed out on the Core 1 in that same PLA. And if you look inside, this has rounded. And if you look inside, this has a chamfered surface. Well, I can see lines on both, but it looks like there are less lines on the chamfer than there is on the fillet. I think we're prototyping here. And so I can't imagine PLA being the final material that CEO Jack wants. I think we've got something good. I'll tell you what, I'm gonna send these over to Jack and let's see what he says.
I like the look at that one. Simple and effective. However, it needs a few changes. I'd like an air hole at the bottom. I'd like the company name on it, and it needs to be made out of ABS material. PLA is great, but I need something more resistant to breakage. Just like Lego bricks. Please make those changes, please.
All right, Jack came back with some notes, and one of them is very significant, which we have to talk about. He wants an air hole in the bottom. Let's just take it from square one. So he wants an air hole at the bottom. Let's make sure that we are on our chamfer at 5mm. Okay, good. And then let's select that surface. Let's do a sketch. And I'm going to do a circle right here. And I'm going to bring it out 28mm. Okay, so exit the sketch. I can select that. And then I should be able to bring it down. Perfect. Goodness, we made an air hole.
Oh, there it is.
As you insert a can into this, there's not a lot of clearance, and so it will fall slowly, which also means as you try to take it out, it's slightly more difficult. With a hole in the bottom, you can push. You can also not have a vacuum, and it should come out a little bit easier. So that's good. He wants the name of the company, Jackaman Inc., on the koozie, which is possible, but I think what we can do is put it on the surface in the slicer rather than in the Shapr3D CAD environment. Now for ABS, it's gonna be difficult in the Core 1. ABS as a material likes it really, really hot. And the build plate on the Core 1 can get up to 110°C, but that chamber temperature is limited to 60°C. But let's give ABS a try in the Core 1 after we add the letters to it. So I've taken this model and I've exported it. Now, let me get my laptop, let me get Prusa Slicer, and let's add the company text to the side of the koozie. Here we go, we're within Prusa Slicer, and I want to add some text to it. It's been a little finicky, but I think we can still do it. So within this environment, I'm going to click on the model, right click, and then I'm going to go to add part, and I'm going to say text. So over here, I'm going to call it Jackaman Inc. And you can see that it is, if I rotate this around, you can see that the text is straight, but the model is curved. So what we can do is say per glyph use surface, that curves it. And then for a depth, what I want to do is 0.5. So rather than the default millimeter it was out, we're just going to have 0.5 millimeter that it's out, and we can adjust that later. Operation is a join. We are good. Okay, so now let's just make sure that we are set up for the correct material, and we've got ABS, Core 1. Let's slice it. Let's see how it looks. Okay, look at that. So this is the speed setting, and if we go to just feature type, so you can see I've got the seam in the back, and it's coming out to fill in those letters, but I do have some blue underneath the letters. So what we can do is go back here. The text is already up. So what I can do now is let's do a 0.3. It's not as far in, and let's slice. Okay, there we go. We can still see Jackaman Inc. It goes up the full 75 millimeters, and it is sticking out. So this is great and really a cool example of utilizing the right tool for the right job. We were able to CAD up a design and then using the slicer, customize that design. And I think that's really going to be something that I explore a lot of going forward. But now let's get this printed up in ABS on the Core 1 and see how it looks. Okay, so I've done 2 different ABS prints in the Core 1 to test out. I'm using some Polymaker Polylite ABS and the Buddy Easy ABS from Prusa. It did a fine job. It did a fine job with what it could do, but the Core 1 isn't really built to handle ABS in the way that other machines might. There's definitely a line at the bottom on both that is very apparent because of the change in geometry, the change in speed, and the temperature within the chamber itself. So that's unfortunate.
Sad.
So that's unfortunate. We need a hotter chamber, really, really hot. And that's where I'm going to utilize the Prusa HT90. The HT90 is the Delta style 3D printer that Prusa got during the Trilabs acquisition. And one of the things that it can do is bring a chamber temperature actively to 90 degrees Celsius. And 90 degrees Celsius is hot enough to overcome the material's likeliness to constrict because of speed differences.
Say again?
What I'm saying is that line shouldn't appear or should be much, much less on a print from the HT90. So let's load some ABS and do it. Here we go, 2 prints in ABS from the HT90, one in the Buddy Easy ABS and one in the Polymaker Polylite ABS. And both look great, but both also don't have that line at the bottom, which is great and what you would expect. And I think that's one of the things that we have to start thinking about is utilizing advanced functionalities in machines to overcome material limitations. With the HT90 going to 90C in the chamber, that's not just making koozies that are slightly better, that's making ABS more dimensionally accurate and with stronger layer bonds. And I think that's important to mention. Well, here we go. Here's the test. ABS does shrink a bit. So unlike the PLA print, 0.5 millimeter is probably not enough, and we'll have to either change the compensation for shrinkage within the slicer or just make our clearance a little wider. But it does have that air hole at the bottom. We can still take it out. And with it being so tight though, it does give you the opportunity to do something really fun with your koozie. Koozie farts.
Yes! That's awesome!
Well, again, this is for a customer, Jack, CEO of Jackaman Inc. Let me get some pictures of the final product over to him and see what he thinks.
Oh my gosh, that is great. I love it. Send me a few. My secretary can take care of the bill. Oh, I'm late for my flight to Tokyo, Japan to go see the Nintendo Museum. Thanks, Uncle Dude. Sean, I need more lemonade.
All right, Jack is happy. We did it. We did it. We went and learned something and at the same time satisfied a customer requirement. And at the end of the day, that's what this is all about. It's just learning something new every day. And today I learned how to use Shapr3D a little bit better. And I learned how to put text on a cylinder in the slicer. And I learned that kids grow up really, really fast. Thanks for watching. If you made it this far, you're awesome. Don't forget to hug each other more, fight for a cause you believe in, and learn more CAD. And as always, high five.